I buskene ved universitetsbygningene på Dragvoll finner vi neste deltakers egne Space Garden. Nederlandske Roos flyttet til Norge for å undersøke det underlige nordlyset vi har, og kan nå gjennom forskningen sin bruke verdensrommet til å forklare hvorfor vi kan finne på å ha det grått og trist her i Trondheim. På fritida handler det også om å komme seg opp i høyden. Ta vel imot Roos de Witt.
Did you see that? That was a shooting star. So I can make a wish. I wish chocolate cake, new skis, to win the lottery. Or, wait a second, I know a good wish for us here in Trondheim. Improved weather forecasts. And shooting stars can help us do just that. Meteorologists need very precise models to know what the weather will do next. Will it rain or will it snow? Now, it turns out it gets a lot easier to know what the weather will do next if we take all the air from the surface all the way up to 100 kilometers, which I'll call the edge of space, because it's so far away, when all this air is included in the models. But before we can put these high layers in the models, we need to know what's going on up there. We need to measure weather at the edge of space. And this is where shooting stars and my research come in. Every day, 50,000 kilograms of space dust comes towards the Earth. But luckily, the atmosphere protects us, and most of this dust burns up before it reaches the Earth. Now, the largest of these burning dust specks we can see as shooting stars. But there's many, many more, much smaller dust specks burning up. These are called meteors. We cannot see them, but we can measure them. Now, when a meteor enters the atmosphere, all the air molecules start to bump into it, and the meteor gets very, very hot. And at about 100 kilometers, it starts to burn up. And when the meteor burns up, it leaves a trail of charged particles behind. And it's this trail that can give us a lot of information about the weather up there. And it's also this trail that we can measure with an instrument called a meteor radar. So get ready to meet my lovely assistant, Morten, the meteor radar. There he is. So Morten can detect meteors by sending out a radio wave or a ping. This ping then travels all the way through the atmosphere until it reaches the meteor trail. And once it reaches this trail, it is reflected back. Now Morten listens, and when it hears the ping again, it knows it has detected a meteor. So far, so good. But how is this going to tell us anything about the weather up there? Well, have you ever seen this trail of clouds left behind by an airplane, and how this trail then moves in the sky? Well, it moves because it's blown with the wind. The same is true for this meteor trail 10 times higher up. So by just checking how fast the trail moves, Morten can measure the wind speeds up there. But that's not all. If you've ever seen a shooting star, you know they disappear very fast, right? It's a flash and they're gone. Now, a meteor trail only takes about 2 seconds to exist. But it depends on the temperature, how fast it disappears. The warmer it is, the faster the trail disappears. So by just checking how long it takes before the trail has disappeared, Morten can also measure the temperatures up there. So by measuring small shooting stars, we can measure weather at the edge of space. Now, if you would like to know how weather at the edge of space can tell us about weather down here, and how it can help us warn oil platform crews about upcoming storms way in advance, you know what to do. Tack för mig.